Welcome back. Today I'm going to talk about one of the most important topics in modern software engineering, the difference between traditional software development and AI software development. Now, whether you're a developer, a tech enthusiast, or just curious about how software is built, this video is going to break down both approaches, how they work, where they shine, and how they're shaping the future of technology. Now, traditional software development is what most developers have been doing for decades. It involves writing code based on logic, rules, and clearly defined outcomes. Developers tell the software, for example, exactly what to do by giving it step-by-step instructions using programming languages like Python, Java. And there are several established methodologies in this space that we use. For instance, the waterfall model follows a strict linear path for each phase is completed before the next begins. Then we have Agile, is more flexible, allowing changes throughout the development cycle. DevOps focuses on integrating development and operations to streamline deployment and updates. Now, in all of these approaches, human developers have full control over what the software does. Every outcome is predefined and traceable back to a specific piece of code. That's traditional software systems are deterministic, right? They behave exactly as programmed. Now, this is ideal for environments where predictability and consistency are critical, such as in banking or enterprise resource planning systems. And everything in the application is manually coded, which includes the business rules, the logic, and workflows. Testing is also usually done manually or through automated scripts that check for expected results. Now, these systems can be rigid and are not well suited for handling uncertainty or learning from data. AI software development takes a completely different approach. Now, instead of explicitly programming every rule, developers now train algorithms using data. Now, these systems learn patterns, make predictions, and adapt over time. For example, a developer building a recommendation engine wouldn't write rules for every type of customer behavior, right? Instead, the developer would feed the system historical data, and the AI would learn which products to recommend based on that historical data. AI development includes areas like machine learning, natural language processing, computer vision, and deep learning. Now, these technologies allow systems to process images, understand speech, interpret language, and improve without manual updates. The development process in AI software is very different from traditional approaches. So in traditional software, for example, the main focus is on designing logic and writing code. Now in AI, it's about collecting and preparing data, selecting models, training them, and then validating them for performance. While traditional development tools are like IDEs, like VS Code, for example, AI development uses platforms like Jupyter Notebook, for example, Python libraries, or TensorFlow, or PyTorch. It often requires a powerful cloud-based GPUs for training. Now, in traditional software, data is an input, right? In AI software, data is the foundation. So, in traditional software, developers are primarily focused on logic, structure, and user experience. While they write functions, they handle errors, and ensure that the application behaves as expected. Now, within the AI development, the developer role expands. Now they must also understand data science a bit, statistics, and algorithms as well. So AI developers become trainers of models. They must analyze data sets, handle bias, select features, and monitor how models perform in the real world. This shift means that collaboration between domain experts, data scientists, and engineers becomes more important than ever. Traditional software performs consistently as long as the code is stable, right? It works exactly the same every single time unless someone changes the logic or the code. Now, AI software, on the other hand, evolves. Well, the more data it gets, the better it performs. That's a double-edged sword, isn't it? On one hand, it can scale and improve. On the other hand, it can be difficult to debug or explain why it made a certain decision. So fixing a bug in traditional software is often straightforward, right? You just go out there, check the code, and fix it. In AI, it can take days to track down a performance issue of poor data or subtle training issue. So traditional development can be slow to adapt. If business rules change, for example, you may have to rewrite the entire modules, right? Now, testing can be time-consuming as well, especially for large systems. Now, in AI development brings its own set of challenges, of course. For example, if the training data is low quality, the model will be unreliable. Models can be biased as well, making unfair decisions, or they can hallucinate. And many AI systems are like black boxes, like hard to understand how they're making decisions. On top of that, performance can degrade over time as well, which requires constant monitoring and retraining. Now, there are areas for each approach that is better suited. Traditional development is ideal for applications that require strict rules, such as accounting, manufacturing, or embedded systems. AI is better for environments that involve large volumes of data or require adaptive learning, or such as fraud detection, recommendation engines, customer service chatbots, or image recognition. Now, many modern applications use both. You can have a hybrid approach. For example, an instance like online shopping store might use traditional logic for checkout and payments, but AI for product recommendations and user personalization. Now, traditional software follows a linear and iterative cycle: gather requirements, design, code, test, and then deploy and maintain. Whereas AI projects begin with problem framing, data requirements. Then comes the data collection, feature engineering, model training, evaluation, and finally deployment. Maintenance in AI means retraining and updating models as data evolves. Now, testing is also different between the two. In traditional software, it's tested through unit tests and system tests, right? And we've been doing that. Now, AI models are evaluated using metrics like accuracy, precision, recall, and confusion matrices. So security is also essential in both approaches, but it plays out differently. So in traditional software, security relies on practices like encryption, authentication, and secure coding, and we all know that. It's about keeping unauthorized users out and protecting data. AI introduces new factors, right? For example, models can be tricked with adversarial inputs. Keep that in mind. Data poisoning is a risk for attackers' corrupt training data. Now, there are also privacy concerns around how data is used to train models. As AI systems grow more powerful, protecting them requires newer techniques like differential privacy and secure model sharing. And traditional development has become fast thanks to version control, CI/CD, all these agents like ChatGPT and agile practices. But it's still limited by the need for manual updates and strict logic structures. Now, AI development is more flexible in that it adapts to new data automatically. But getting started can be slow and expensive at the same time. Training large models requires powerful hardware, GPUs, specialized talent, and high-quality labeled datasets. But once an AI system is up and running, it can deliver a tremendous value by automating tasks and uncovering patterns that the traditional systems will miss. So traditional software teams typically include a front end and a back end, right? Testers, project managers, QAs. AI projects require additional expertise. You need data scientists, right? You need machine learning engineers. You need AI engineers. You need, AI ethicists, for example, right? So handling data responsibly, ensuring fairness, and building explainable systems are part of the development process now. In AI development, coding is still important because we need that. But understanding data, statistics, and model behavior is equally critical. So the future isn't about choosing one approach or the other. In my opinion, it's about combining both the traditional software or coming up with a hybrid system, which is becoming a norm. A traditional web app might use AI to personalize user content. A CRM system might use machine learning to predict customer churn while using traditional code for its interface and workflows. So AI is also transforming the development process itself. Tools like GitHub Copilot, for example, Claude Sonnet that I use every day, helps you write code faster. It's not just what we build, it's becoming how we build things. So, if you like this video, make sure you like, comment, and subscribe. And let me know in comments down below what you think about the differences between traditional versus AI software development. My name is Syed. Thanks for watching. I'll see you next time.